Hi everyone, I am Asaf, your instructor for this course. I would like to welcome you to my course, Python Statistical Methods for Machine Learning and Data Science. This section is important to watch because a lot of important materials will be covered, such as where to download the Jupyter notebooks for this course, including the exercises and the projects. So please don't skip the lectures in this section. In this lecture, I will give a brief overview of the course curriculum. This course begins with Module 1, which is the introduction. In this module, I will give an overview of the course curriculum. I will also explain to you how to download the exercises, the projects, and the course notebooks. And I will show you how to install the Jupyter Notebook environment in case it is not already installed on your computer. In Module 2, Real Learning will begin. I will introduce you to the most common built-in data structures in Python, as well as NumPy arrays and Pandas data frames. You will also learn how to classify data into its data type, such as numerical and categorical data. In Module 3 and Module 4, I will discuss the exploratory data analysis that deals with central tendency measures, such as the mean and the median. Also, the variability measures such as the variance, standard deviation, and percentiles. And I will explain important statistical concepts, the population and the sample in statistics, outliers, and sampling error. In Module 5, you will study data visualizations and data distributions in Python, such as box plots, Veillon plots, histograms, and density plots, which are used to explore data distribution. In Module 6, you will learn how to calculate correlations between variables and visualize the correlation between two or more variables using scatter plots and heat maps. Module 7 is a capstone project for you, so you will get your hands dirty with coding regarding the skills and techniques that you learned in the previous sections. In Module 8, you will learn in detail the most common probability distributions in statistics, focusing on the normal distribution and how to apply normality tests in Python for real-world data. You will also learn about skewness and skewed data. In Module 9, you will learn very important pre-processing techniques in data science and machine learning, which are data scaling and transformation. You will learn how to standardize data to have the same scale, and you will learn also different transformation methods to deal with skewed data to make them normally distributed. In Module 10, I will discuss confidence interval in statistics and how it can be performed in Python for continuous and classification data. You will also learn the bootstrapping method, which becomes a famous method in modern statistical data analysis and data science. Module 11 and 12 will cover very important statistical methods in machine learning, model evaluation, and model validation. These methods are a must to learn for all data scientists. You will also learn very important statistical concepts in modeling: bias, variance, overfitting, and underfitting. Understanding these terms are vital for evaluating machine learning models. Model evaluation and validation techniques will be explained in a practical way using real-world data with different types of machine learning models. Module 13 is the final hands-on project of this course. In the project description, you will find the specific tasks that you will need to perform to finish the project. In this module, I included a suggested solution for the project with a walkthrough step-by-step explanations for the solution of the tasks. It's worth mentioning here that at the end of most modules, there are extra exercises for you to practice what you learned in the lectures. In the next lecture, I will show you how to install Jupyter Notebook environment on your local computer. Thanks for watching and see you there.